So today we're going to be working on word problems. Now, solving them is going to be the same as we've been using over the past few days. We're going to use substitution, we are going to use linear combination, but it's the writing of the systems that's going to be a little bit new. So we're going to have to take the word problem it gives us, write our systems, and then use the methods we've been using to solve them. Now, these notes are in your book, so make sure you are on the right page in your book and ready to go. So a college student only saves nickels and dimes in her piggy bank because she uses the quarters to do her laundry, and she does not save any pennies. She empties out her piggy bank at the end of each month. This month, there are 56 total coins in her piggy bank, and the value is $4.55. We want to know how many of each coin she has. So one thing you always want to look for whenever you're given a word problem with systems, you want to look for totals. So in this one, I see two totals. There is a total of 56 coins and a total value of $4.55. They may not use specifically the word total, but any values they give you that are totaling something up, those are the ones you want to look for. Because if you are given those values, your equation is always going to be equal to those numbers. So since one of our totals was 56, one of our equations will be equals 56. And since the other total they gave us was $4.55, the other equation will be equal to $4.55. So since they have totals, since they're equal to a number, these are going to both be in standard form. AX plus BY equals C. Now we don't specifically have to use X and Y. We could use any variables we want, but they are going to be in standard form. So the variables will be on the same side. So the first total was 56 coins. So everything having to do with coins is going to go in this first equation. So we have to think about what coins they said she's going to be saving. Well, she saves some nickels and she saves some dimes. So those are going to be in with our total coins. The amount of nickels she has plus the amount of dimes she has equals the total 56 coins. $4.55, that was money. So everything having to do with money is going to go in this second problem. Now, nowhere else in this word problem did they give us money, but we have to read between the lines. We have to use our prior knowledge to figure out what goes in for money. Now, we know that a nickel is worth 5 cents. So we're going to say 5 cents for the nickels, plus a dime is worth 10 cents. So 10 cents for the dimes. And make sure you put the decimals in here. If you did this problem without decimals, if you wrote 5N, that's $5. And 10D, that would be $10. So you definitely want to make sure that you are using cents and not dollars. So now we have our system of equations. Since they're in standard form, we are going to want to use linear combination here. Now the second one has a positive 0.05n, so I want to make the first one be a negative 0.05n to make them cancel. So I'm going to multiply everything in this first equation times negative 0.05 or 0.05, either one is fine. And in doing that, I'm going to get something that eliminates the ends. So make sure you distribute it to every single variable, to N, to D, and to the total at the end. So I now have negative 0.05N minus 0.05D equals, and then I have to do 56 times negative 0.05 and get negative 2.8. And we keep solving. The ends eliminate here and we combine our like terms. So 0.10D minus 0.05D would be 0.05D. And that equals, then we combine our totals, we get 1.75. Once we divide both sides by 0.05, we're going to get our solution. We get that the amount of dimes is 35. So I'm going to label that 35 dimes. So we're going to take that answer, substitute it back into one of the two original equations. Well, our second equation over here has a ton of decimals. The first one doesn't have any decimals, so I would recommend using n plus d equals 56. It's going to make it a little bit easier. So the number of nickels plus the 35 dimes we just got equals 56 total coins. Then we're going to subtract 35 from both sides. To get the amount of nickels equals 21. So here's how many coins she has: 21 nickels and 35 dimes. So the next one says it will take 8 hours to complete a certain print job. The company can do the job for $80. The supervisor of the company, who is paid $15 per hour, will start the job, and the assistant, who is paid $7 an hour, will take over and complete the job once the supervisor leaves. We want to know how long each person will work here. So again, the first thing you want to do is look for any totals they may give you, even if they don't use the word totals. So they're going to work a total of 8 hours, and it is going to cost a total of $80. So one of our equations will equal 8, and the other equation will equal 80. Now again, use the labels to help you figure out the rest of the equations. So 8 was the hours, and 80 here was money. Now they asked us how long will each person work. So that's what we're trying to find here. I'm going to use S as the supervisor hours. And I'm going to use A for the assistant hours. So let's use our variables and the totals we have to create our equations. The first one, since 8 was hours, everything having to do with hours goes in the first equation. So the supervisor hours plus the assistant hours has to equal the 8 total hours. And everything having to do with money goes in the second equation. It's $15 for the supervisor, and it's $7 for the assistant. Now that we have our two equations, we're going to have to multiply and use linear combination to solve this. Since neither of them say S equals or A equals, that's why we're using linear combination. Now it's up to you if you want to eliminate S or if you want to eliminate A. Since A is a smaller number here, 7A, I'm going to use A on this one. So if the second equation is a positive 7A, I need the first equation to be a negative 7A. So I'm going to multiply everything in that first equation times negative 7. So I have negative 7S minus 7A equals negative 56. The A's eliminate and we just keep solving. So 15S minus 8S gives us 8S. And we have 80 minus 56, which is 24. Divide both sides by 8 to get S equals 3. So the supervisor is going to work 3 hours. We substitute that value back in to get our second part of our answer. So the supervisor's working 3 hours, plus however long the assistant works, has to equal the 8 total hours. We subtract 3 from both sides to get that the assistant works 5 hours as our second part of the solution. So Angela and Jasmine are paying off their credit card debt. Angela is starting out with $120 in debt and plans to pay $1 every day. Jasmine is starting $150 in debt and plans to pay $2 each day. At what day will Angela and Jasmine be at the same amount? Again, we are going to look for any totals they give us. So as I'm looking here, they gave us starting amounts. They told us how much they're going to pay each day, but they didn't give us any totals. Okay. So because we don't have any totals, that means that both of these equations are going to be in slope-intercept form. They're going to start with y equals. And then we have to figure it out from there, how we write our equations. Now, since they're both in debt, there are a few ways you can write the equation. You could say for Angela that she is $120 in debt, but she plans to decrease her debt by $1 per day. Now, that absolutely works. That is completely fine. But another way to look at it is to say, well, if you're in debt, you owe money. It's negative. So she starts at negative $120, and she is adding $1 each day by paying off $1 to it each day. Either one of those is fine, but you have to be consistent. Whichever way you do it in the first equation, you have to do it the same way in the second equation. And again, notice, both of the signs are opposite. If the 120 was negative, the 1x is positive. If the 120 is positive, the 1x is negative. So again, if you thought of it one way rather than the other, that is completely fine. You just have to stay consistent. I'm going to start with this top way. I'm going to say that she started $120 in debt and she's paying down that debt. So she's subtracting $1 of debt each day. For Jasmine, she started out with $150 of debt, and she is taking away $2 of debt each day. So I'm using X for days. You could have also used D, whatever you want to do. And it asks, at what day is their debt the same amount? So since these both say y equals, instead of using linear combination, we are going to use substitution here. Going to take what y is equal to in the first equation and substitute it in place of y in the second equation. So we get 120 minus 1x equals 150 minus 2x. And we solve. We need to solve for our x's here. So I'm going to get all my x's to one side by adding 2x over to the left. And I have 120 plus x equals 150. Now, if all the x's are on the left, we need to get all of our constants or our numbers to the right. So I'm going to subtract the 120 over to the right to get x equals 30. Well, at this point, x is by itself, and again, x was our number of days. So this is telling me at 30 days, they will have the same amount of debt. Now, notice in the problem, they never asked me how much debt they would have. They just asked after how many days would they have the same amount of debt. We answered that by only finding x. So if you answer the question with just one part of the problem, you're done. We don't need to find how much debt they have because they didn't ask us. Our answer is at 30 days, they will have the same amount of debt, and that's it for this problem. I'm going to jump down here to number 5. You are ordering softballs for 2 softball leagues. The Pony League uses 11-inch balls that are priced at $2.75, and the Junior League uses the 12-inch ball that is priced at $3.25. If you purchase 80 total balls for $245, find how many of each size you need. So I need to know how many Pony League balls we need and how many Junior League softballs we need. So I'm going to use P for the Pony League. And I'm going to use J for the Junior League. So we again look for any totals they may have given us. So it said that we purchased a total of 80 softballs for a total of $245. Again, they didn't use the word totals. We had to figure out which of these values were our overall price and our overall amount that we ordered. So one of my equations is going to be equal to 80, while the other equation is going to be equal to 245. Now 80 was the number of softballs, so everything having to do with softballs goes in the first equation. We ordered some amount of softballs for the Pony League and some amount of softballs for the Junior League. We don't know how many, so we just put the variables. The second equation was money. $245 was money, so we are going to put everything having to do with money in this second equation. It costs $2.75 for the Pony League softballs, and it costs $3.25 for the Junior League softballs. So we now have our two equations, and since they are in standard form, we're going to have to use the linear combination to solve this one. So I'm going to eliminate P on this one. We have $2.75 for the money, so I'm going to need this to be a negative $2.75 for them to eliminate. So I'm going to multiply everything in that first equation times $2 or negative $2.75. And I get negative 2.75p minus 2.75j, and that equals 80 times negative 2.75, which is negative 220. So the p's eliminate here. We do 3.25 minus 2.75 and get 0.5j equals, and then we subtract our constants, 25. So now we have to divide by 0.5. And when you do 25 divided by 0.5, you get that they ordered 50 Junior League softballs. So we substitute this back into the first equation. Again, because the first equation doesn't have decimals, it's a little bit easier. The amount of Pony League softballs they ordered, plus the 50 softballs they just ordered for Junior League, has to equal the 80 total softballs that they ordered. So we subtract 50 here, and we get that P equals 30 softballs. Now, if you feel prepared, if you feel like you understand this, feel free to stop the video. If you want to see a few more problems, I'll do a few more just so that you can get a little more understanding of what's going on with the word problems. So let's head down to question number 7. Bill and Mike are trying to lose weight. Bill initially weighed 200 pounds and is losing half a pound each week. Mike initially weighed 225 pounds and is losing 1 pound per week. We want to know when they will weigh the same amount. So again, we're looking for totals that they gave us. Well, they told me how much Bill started weighing and how much Mike started by weighing, but they don't tell me a total. I don't know how much total they want to lose. I don't know anything about a total. So these are not going to be in standard form. These are going to be in slope-intercept form. Since they're talking about two people, Bill and Mike, one entire equation will be about Bill, one entire equation will be about Mike. So Bill started off by weighing 200 pounds, and he is losing half a pound each week. So since he is losing weight, he is subtracting half a pound each week. And I'm going to use W for weeks. You could have used X, whatever you want to use. Mike is 225 pounds to begin with, and he is losing 1 pound each week. So since both of these say y equals, we are going to use substitution to solve this. I take what y is equal to in one of the equations and substitute it in to the other equation. So 200 minus 0.5w equals 225 minus 1w. We need to get all of our variables to one side, so I'm going to add 1w over to the left and get 200 plus 0.5w equals 225. Since all the w's are on the left, I need to get all the constants to the right. So I'm going to subtract the 200 to get 0.5w equals 25. And our last step here is to divide both sides by 0.5. And you get that w equals 50. Now again, w stood for the number of weeks. So that's after 50 weeks, they're going to weigh the same amount. Notice that's the question they asked us. They didn't ask us how much they were going to weigh. They asked us when will they weigh the same amount. The answer is 50 weeks. Once you have answered it, you're done. You don't need to keep going with the problem.